Welcome to Study Loop.
Hello and welcome back. We're now into Chapter 13, Problem 26. And we are referring to Figure 13.5, which we're going to go look at here in a moment. But let's look at the question first. We need to determine mass. So if we're determining mass, that's what we're solving for. We are solving for some type of grams. Of each of the following salts required to form a saturated solution in 250 grams of water. So we know that they're in 250 grams of water. Oh, that's H2O. And it has to be at 30 degrees Celsius. So that's a lot of specific info they gave us, but hopefully this figure will help us solve this directly. But we will have three different salts that we're looking at specifically. Let's write those down. Potassium chlorate, lead nitrate, and then cesium sulfate. So let's bring that up now. All right, flipping back in our book, we found that we have figure 13.15. We've brought it up here. So this is what we're looking at now. So let's dig in and find out what we have here. Well, before we dig in, what did we need to find? We needed to solve grams in a 250 gram solution of water. So looking at this chart, we find that we have 100 grams. So that doesn't match up identically, but that's okay. We will find a way to make it work all the same. All right, and it has to be at 30 degrees Celsius. Well, look at this. We have a temperature chart. So everything here, we can find the solubility at a specific temperature. This is perfect for us. That's what we love. So let's see what we're given. We had three salts. So if we remember what they are, A was our potassium chlorate, ClO3. And then we found we had a different salt for B. That was lead. Perfect. Lead, Pb. Nitrate, NO3. See? And then we have cesium sulfate. If you don't remember these polyatomics, go back and watch a video because these polyatomics come up a lot on tests. All right, so let's go back to this graph here. We have potassium chlorate. Let's see where that is. Right here, we have potassium chlorate, and we needed it at 30 degrees Celsius. So let's find 30 degrees Celsius and potassium chlorate right here. We find that we have 10 grams of this salt for every 100 grams of water in a saturated solution. So let's dig out information on lead nitrate. We have lead nitrate here, and let's find it at 30 degrees. It's almost right smack in the center here at 65 grams. If you've been working this problem prior to this and you ended up with 70, maybe a little bit higher, 63 grams, anything close to this, it's just an approximation whenever we're using a graph. If they wanted something more precise, they would have given us numbers. All right, let's find cesium. Cesium sulfate is down here at the bottom, and I'm just going to guesstimate that that is possibly, about 3 grams here. 3 grams for every 100 grams. So now that we have broken down what we needed, which is to find grams or mass of salt in a 250 gram saturated solution at 30 degrees Celsius, we know what we need to find and we know what we've been given. How do we convert? You can pause this video right now and see if you can figure it out on your own. So let's work it out together. We know we have 250 grams of solution that we need. And then we have all of these that we found from the graph. So we know that we have an A salt, a B salt, or sea salt in grams over 100 grams of water. So we can use stoichiometry to get rid of our grams of water and end up with just grams of salt. So let's put it into our calculator. We put 250 grams times 10 divided by 100, and we end up with 25 grams of potassium chlorate. Let's do this again for B. And we take 250 times 65 divided by 100, and we find that we have 162.5 grams. We're going to round that to 160 grams. Here we have cesium. So we're going to take that 250 times 3 divided by 100, and we find we get 7.5 grams. We've got one sig fig here that we guesstimated with, so we're going to go and down to one sig fig, and that is 8 grams. Excellent. See if you can work the next problem on your own.